Suppose you are given with a question in your workplace, and that question is related to this process. Give a try to answer these questions before starting. Which equipment or unit operations are used in two-stage compression? It was so easy, right? One more thing comes for you. Do you still remember how to add the streams and unit operations? If yes, let's get started. As you are already familiar with the process, you should have a perspective to grasp the aim of two-stage compression. Basically, the purpose of a two-stage compression is either to increase the pressure to the level where a single stage cannot deal with, or to improve the efficiency. As you do remember, in order to build up the simulation, you should give it a hand by defining the simulation basis. Firstly, you're defining the property package and then adding the components for the process. For the model we're building up, we'll choose the mostly used property package called Peng-Robinson, of course, and enter the following components. Nitrogen, carbon dioxide, methane, ethane, propane, isobutane, normal butane, iso and normal pentane, and finally the normal hexane. After being done with defining the simulation, click on the simulation environment to start building up the simulation. The necessary point to note is, we will build up the simulation without inserting the recycling. In the next video, you will see a clear explanation associated with this part as well. Excellent! This blank environment with its amazing front object palette waits for the streams and unit operations. Alright, let's feed our environment. Use object palette to add the material stream called to compression. The material stream is shown as blue arrow in the palette and given with the following values. Enter 35 degrees for the temperature and 1725 kPa for pressure and a molar flow rate of 5000 kg/mol per hour. Your stream cannot be specified without entering the composition for that, because all the components within the combination do have their specific properties. So, entering the identity about them will perfectly specify the material stream you're adding to the simulation. Let's add the following mole fractions. Now, add the mixer called Mixer 1 by using Object Palette again. See Object Palette search box and write Mixer to add it into the simulation. Well, take it up and bring it near to the material stream. It is so basic that Mixer should have at least 2 streams to be mixed up and create a new single stream. However, as we have mentioned, in this video we are not going to insert the recycling. Okay, after this valuable information, we can come to the mixer, which is waiting for being specified. Double-click on the mixer to see its specifications. Write Mixer 1 for its name. Link it with inlet off to compression stream that we have already added. Give an outlet off to LP separator stream, which is automatically going to be created. Then come to the parameters and change the pressure assignment to equalize all, because you are dealing with gases which are so sensitive fluids, right? And later on, close the window and continue with adding other unit operations. Add the separator to separate the stream into the phases within an appropriate operating conditions. For this, just use Object Palette and drop 2-phase separator from the list, because we don't have a large water content, and even we don't have a water content at all to add 3-phase separator, right? Then call it as LP or low pressure separator. and write the following names for the vapor and liquid outlets of the equipment. Well, now we're going to add the compressor, which is the starting point in a two-stage compression. Come to the lovely object palette, see compressor and drop it into the environment. Let's write stage 1 for its name. Set its inlet to low pressure separator vapor stream, which is vapor outlet from low pressure separator. And then link the automatic streams of stage 1 out for outlet and stage 1 HP for energy stream. Okay, now come to the parameters and make sure that adiabatic efficiency is 75%. Nice. We have used the compressor, so we need to compress the stream to some high pressure, right? So we are given with the outlet stream pressure, so that come to the worksheet tab and write pressure value of 3450 kPa for stage 1 out material stream. During this, the HYSYS does the automatic calculations to reveal an unknown duty for a compressor. Then we will add the next unit operation called cooler to cool down the stream, leaving the compressor, and complete the stage 1 for compression. In order to do this, take a cooler from the object palette and write stage 1 cooler for its name. Then set the inlet and outlet streams, like stage 1 out for the inlet and cooler 1 out for the outlet stream. Oh, we forgot something. The energy stream, to remove the excess heat, we have to add it. Add the energy stream to remove the excess heat, called stage 1Q. Then come to the parameters and note that we don't want to have a pressure drop, so write down 0 for that. And most important thing, come to the worksheet for cooler, set the outlet temperature for the stream, leaving it 50 degrees Celsius for instance. Now, you can see that all the other parameters are defined by HYSYS with its useful data input. And right now, we're gonna follow the same procedure to develop the second stage of the two-stage compression. Do you remember what we have started with? I can hear that you say mixer. Yeah, we'll add the mixer called mixer 2, and then connect it to the inlet of cooler 1 out. And leaving it with 2 IS separator material stream. Also, we have to change pressure assignment to equalize all, as we did for the first stage. Then you will need a further separation for better efficiency, so install the separator from the object palette. Link its inlet to 2IS separator material stream and define its liquid and vapor outlet streams as IS separator vapor and IS separator liquid. The IS can be the abbreviation of intermediate separation. After intermediate separation, we should deal with both its liquid and vapor streams. First, come to its liquid stream, leaving it at the bottom. Use valve to decrease its pressure, maybe to meet some design conditions of the pipeline, for instance. For this, drop the control valve from the palette. Name it as letdown 1. Take inlet of IS separated liquid and automatic outlet of LD1 out. And then come to the worksheet to operate the valve. Set its outlet pressure to 1725 kPa. We don't stop because our desire for the pressure is very high, and so we should reach that value. For this, take another compressor, name it as stage 2. And take IS separated vapor as the inlet and stage 2 out as an outlet for that. Moreover, use stage 2 HP energy stream to compress the inlet. Later, come to the parameters and make sure that adiabatic efficiency is 75%. Then, see the worksheet tab and define the pressure of the compressor outlet as 6,900 kPa. Alright, now the hot and high pressurized stream is underway, so we will again need the cooler to meet the design conditions of the pipeline. Install the second cooler and name it as stage 2 cooler with an inlet of stage 2 out. And link an outlet of that with cooler 2 out material stream and with the energy stream of stage 2Q. Let's say again within this cooling process, we don't want to lose pressure. So set up the delta P to 0 and define the cooler outlet temperature of 50 degrees Celsius from the worksheet. And now it is time to add the final separator, which is high pressure separator, accepts the stream with the high pressure. For this, drop the separator from the object palette and write HP separator for its name. And then take the cooler 2 out as the inlet and define its liquid and vapor outlet streams as HP separated vapor and HP separated liquid. After the last separation, the vapor outlet is taken as a product and the liquid outlet will be dealt with for further recycling. We'll again use valve called letdown 2 for this. Drop control valve from the palette, name it as letdown 2. And take the inlet of HP separated liquid and automatic outlet of LD2 out. And then come to the worksheet to operate the valve. Set the outlet pressure to 3,450 kPa. Amazing! We're done with the most important part of building the simulation. Save your case now, and note that the only operations missing at this point are the recycles, as we have mentioned earlier. We'll complete our simulation with the final slight touches of the recycle that we will enroll in the next video. Say practice a lot, keep it up, and be ready for the upcoming videos. I'll see you soon.